Hey, hi, Deepak here. Today I'm gonna cover a very important question on MapReduce and also interview question how to submit and how to monitor the MapReduce job. So the most critical part, we will answer here how to do that. So for that, there is a job class in MapReduce called job, which is a primary method which is used to manage all the triggering of job and monitoring the status of the job and taking care of all the internal activities. Now I'm going to answer few things. One is how to do the submission of the job, and second thing is how what do you do when you are what kind of options are what taken care by the job submission, by the job class what it takes care. Third is how you can check the MapReduce job output. So, so let us check this. Let us see this. So, um, job is we will look at the job and the code also. So, job is basically it checks all the input and output specifications. It checks whether the input directory exists, the output directory should not exist. That it is checking. It is taken care. Within the job, when we call the mapper, it calls the input split process to split the files. The input split process is taken care by calling the mapper job from the job. And the job also very important third thing inside the job is it is gonna take care of passing the distributed cache and any archive files or any executables that you want also to be part of the mapper job. But basically you would like your job to contain a method through which you would like to transfer any lookups or distributed cache kind of files which are used in all the mappers at the same time. So that kind of data if you want to transfer across to all your mapped jobs, you can the job will take care of that distributed job and part, and it will kind of, as I mentioned, it does that. So let us look at the four. So these are the, as I said, these we looked at the four important key points, which is taken care by the job. It submits the job. It helps in monitoring. It checks whether the job directories are all present, input directory, output directory. Then it is going to load the distributed cache files, the caches files to cross all the different nodes that mapper jobs. It is going to transfer it, and also the reducer nodes wherever the reduce operation take in place. So it also calls the output committer processes that exist, which ensures that any temporary files that are needed for the job creation, any temporary files needed are all created, and also when the job is complete, the temporary files are deleted. So these five things jobs will do, the job class will do. And let us look at the way through which you can look at the job history. There's command mapper job history to check the history of the commands which are executed. So the job submission. So if you see here, the job submission is taken care by mainly a command called job submit, and then in your MapReduce job you will be waiting for the job to complete. There's a function which returns whether the job is completed or not, and if it is complete you exit, otherwise you wait. So now all this whatever theory, all this which I have mentioned, this which I have just told is all theory. We'll look at a practical example. So let us look at the basic word count code. Let's see this. Here, this my MapReduce program exists where there is an main Java main class. It's a static class which returns nothing. The main class which takes the parameters. Now you will see that a very important class is called a configuration is first created, which is which gives the parameters that are needed for the job, and you can even pass job parameters further. But this configuration class is first critical, which is calling this Hadoop or Apache Hadoop configuration. Now, from this, you are going to create get an instance for this job. So it is job get inst function called get instance of job, where you pass the config class and you give the name of that job. Next, in the job you are defining everything. Like you can define the mapper class, the reducer, the the output key class, output value, all that can be defined. This is a mapper output, mapper output key, mapper output values, etc. All this you can define it using the all this can be the parameters can be defined. And this is a job you can for a file inputs format, you can give the add that file input path to the you are adding that input path for the file input format to the job and give the argument that you're passing. And once you can just submit a job, or you can say job wait for completion. If it is true, then you exit, otherwise you keep, otherwise you wait till. If it is 1, then the system will exit with error, otherwise it is 0, it is fine. So uh, system exit 1 means it will wait. So whenever it is complete, that means system exit input will be 0 and it will exit. So let us have this thing running. uh, so I hope you have look at understood a job class, which is important in every MapReduce program. So let us this is my local Cloudera VM. So let us look at simple. Um, so let us look at this simple command. It is we are just going to run this, and we are going to run using this yarn jar command or a Hadoop jar. Pass the class name. This class name word count is this. This is the class name word count. You will pass that, and then you pass the parameter, the input and the output location. Output location should not exist, so you have to take care of that. And we will be creating a jar file using a Hadoop jar command for all the classes that exist uh, in our Java file. And then you just hit enter. It will should run. This guy will run now. Okay, say output already exists. Very good. So let's make another thing hmm, which should not exist. So as you saw, the job command, it checked whether the output directory exists. If it doesn't exist, then only it will start. So that it is doing its job properly. And then it says, okay, it started creating the application using application master. There is a URL given. You can use this URL to monitor the job also. Now let us we can I accidentally clicked on uh, Control C, so it got cancelled. That is fine. You can come on, why are you doing this? It's not copying. Nine, nine. So we can check this application ID here. It's taking a little time to run. Come on. Okay, so I don't know. It's still running. It seems. Hmm. uh, So the jobs are running. The map job is completed, and now the reduce job will start triggering. So you can see that can look at the map job. There are two files in the input directory, so there are two map jobs. Otherwise, there will be if there is a single file, there will be one job. Click on logs. You can see some logs. Surprisingly, this is slow. I don't know. It's very small data. It is still slow. It's not generating. Showing me the log. Fail log not configured. Maybe I need to restart my Hadoop. It will probably work faster. But you can see the counters, data count, job counters. We want to see. So the job is now completed. You can see counters like number bytes, how much byte was read, how much bytes written, how much number of total HDFS bytes, how much read, how much written in HDFS, um, number of read, write operation, all that. So reduce operation, how much map operation, how much, all that. So you get to know all these details. You can get all the counter details for map, reduce, and total tasks here. So okay, so I think this is a very long video, but I hope you guys understood this basics of MapReduce job execution. And let us look at the output also. Let us quickly check what output is generated here. Uh, so use this list command. Check this. Check the water files are generated. So you have a success, which means that the reducer has done its job properly. That what it means. Let us look at this file. So come on. It's very so slow. So you can see it has counted a group to the data by the word Hadoop, and each word has been summed up. The word count is done. So thanks for watching. I'll keep creating more videos, a lot of videos. Bye.